In this video, we are going to cover trig identities, which is a topic that grade 11 secondary school students feels that is difficult. So identities, you have seen many identities before. As long as equals, they are identities. So we expand 3 times x minus 1, you have 3x minus 3, that is a identities. And also if we have 3a divided by a, we cancel the a out, equals 3. This is identities, but it has a restriction that a couldn't be 0. And for the trig identities, formula tangent x equals sine x over cosine x. Cosine x couldn't be 0. This is identities too, but we call this one because it has a trig ratios, so we call it trig identities. In order to prove the identities are true, so we are going to make use of certain identities that we have known before. So this is a hexagon, and if you know how to use this hexagon, you are able to remember all the trig identities that you have could use to prove other trig identities. So this one, how to use it is tangent equals sine theta divided by cosine theta. And it's true, sine theta equals cosine theta divided by cotangent theta. All go backward. So cotangent theta equals cosine theta divided by sine theta. So either go clockwise or counterclockwise, equals divide, you could have one trig identity. And another one is the opposite term. They are the reciprocal identities. So sine theta equals 1 divided by cosine. This is division. 1 divided by cosine, cosecant. And cosine theta equals 1 divided by secant. So they are reciprocal for the diagonals. And tangent theta equals 1 divided by cotangent theta. And worthwise. So cotangent theta, also you could write it as 1 divided by tangent theta. And same thing for the other, secant theta equals 1 divided by cosine theta, cosecant theta equals 1 divided by sine theta. So we put all those trig identities you could use in this chart. So this is cosecant theta equals 1 divided by sine, secant equals 1 divided by cosine, cotangent equals 1 divided by tangent. And how to remember it is the first letter not same. So cosecant theta is not 1 over cosine theta. First letter need to be different. Cotangent is 1 over tangent. And the quotient identities, tangent theta equals sine divided by cosine. That is for this one, cotangent theta equals cosine theta divided by sine theta. And also you could go from here, cosecant equals cotangent divided by cosine theta. So it's just equals divide. This one equals divide. So you could use this hexagon to get more trig identities you could use. And the Pythagorean identities, this is very important. The sine theta squared, these 3 colored triangles, the 2 terms on the top squared, add together equals bottom 1 equals 1. 1 squared plus cotangent squared equals cosecant squared. This is a blue triangle. And this is a yellow triangle. Tangent theta squared plus 1 squared equals secant squared. So this is a red triangle. This is a blue one. This is a yellow. And how to remember this hexagon is just you start from this one, tangent equals sine cosine. So you have these 3 terms, then all others just reciprocal. Tan reciprocal cotangent, sine, cosecant, cosine, secant, then put 1 at the middle. Then after that, you will have these two squared together equal this. So just continue to do it, then you will have all these trig identities. So after that, we are going to use several examples to see how we could prove x equation is equals left side equals right side is use trig identities to prove the equal sign is true. And there are several strategies you could use is start from the most complicated side and try to change it to the other side. If doesn't work, you could work on both sides until they look identical. Rewrite all trig ratios in terms of sine, cosine if you are not quite familiar with other ratios. If they are fractions, try to use a common denominator to make it numerator or denominator for the left side and the right side. And also to try factoring and cancel if you have fractions. So factor them, then try to cancel some common factor out. Difference of squares often appears. So different squares, how to get them is from the Pythagorean identities. So sine squared plus cosine squared x equals 1. You could move the cosine squared to other side. Then you will have 1 squared minus cosine squared x. And you move the sine squared other side, you will have cosine squared x equals 1 minus sine squared x. And because this is difference of squares, so we could write it as a plus b times a minus b. Then this is by using this, you could factor the something and cancel something. So 1 minus sine squared, we could write it as 1 plus sine x and 1 minus sine x. So these are the trig identities you use a lot to do the proof. So this is what you need to have to do the trig identities proof. So first example, prove that 1 plus cotangent squared theta equals cosecant squared theta. And we know this is from the hexagon. But because it asks you to prove, so we are going to use this hexagon to prove more complicated trig identities proof. But for this, it's an easy one. We are going to start from the very beginning. So we draw this hexagon and we start from tangent theta equals sine theta divided by cosine theta. So this is how we start to create this hexagon. And after that, we write a reciprocal to the diagonal vertex. So tangent theta is cotangent theta is reciprocal, sine is cosecant theta reciprocal, cosine is secant reciprocal. And once we have it, you are going to have this Pythagorean. So we have the reciprocal, we have the tangent theta, we have cotangent theta equals cosine divided by sine. So we have reciprocal identities and the quotient identities. Then the Pythagorean is top 2 sine squared plus cosine squared equals the bottom one. So this one tangent square theta, this is a 3 triangle this way, tangent square theta plus 1 equals secant squared. And this one 1 plus cotangent squared theta equals cosecant squared theta. And this question asks you to prove the last one, so we are going to try to use a sine and the cosine to prove it. So left side, we use a first letter for left side, ls, left side, represent left side, equals 1 plus cotangent theta is cosine squared. Cosine theta divided by sine theta is cotangent theta, and squared, we just squared both. Then we continue. This is a fraction plus an integer, so we want to change both to the same denominator. So the first one, we are going to times sine squared theta. So we are going to have sine squared theta divided by sine squared theta. So times 1 with sine squared. We still have 1, but we have same denominator now. So I don't want to rewrite the second term. We have same denominator. We could just add numerator together. And sine squared plus cosine squared, we know equals 1. That is Pythagorean identity. So we have 1 divided by sine squared theta. So this is a left side. We could do the right side. Equals cosecant reciprocal of sine. So 1 over sine is your cosecant theta and a squared. So check left side equals right side. Then therefore it is proven. So this is our first trig identities you have proved. And also another way, you don't have to rewrite the right side. You could just convert this one. So this is a second way you can prove it is from here we continue 1 over sine is cosecant. Then equals right side. Then you could go from here, left side equal right side is proven. So this is another way you could write it. So it's just second method you could write, okay? From one side, keep going to prove it equals the right side. So that is for example 1. And we call this one is kind of like the first principle identities. We need to prove it from the very beginning, okay? And the second one, and also the first one, why we start from the left side, because it has 2 terms, more complicated side. So we start from the left side. And for the second example, we are going to see it is prove that tangent theta equals sine theta plus sine squared theta over cosine theta times 1 plus sine theta. You could pause here and do the proof, and after that, check. If you stuck, you can come back and check if you got it proved. So this one, we are going to start from the more complicated side, that is the right side. So we start from the right side. And for the numerator, we want to do the factor, because if we factor it, we may have something we can cancel out. So sine theta plus sine theta squared, the common is sine theta. Common factor sine theta, then each term divided by sine theta. Sine theta divided by sine theta is 1, not 0, it's not subtraction. Same thing, divide is 1. Sine squared theta divided by sine theta, the degree subtract 2 minus 1 give you 1. So we have sine theta left. Then divide by the denominator, we try not to expand. We always want to try factoring, because after factoring, we may able to cancel something out for the fractions, rational expression. Then you will see in the bracket, these 2 brackets are 2 factors. They are same. So 1 plus sine theta, 1 plus sine theta, they are same. We can cancel out. Is 1. Then we are going to have sine theta divided by cosine theta. And we know that this is from quotient identity. Sine theta divided by cosine theta is tangent theta. And that is your left side. Then right side equals left side, therefore it is proven. So this is another trig identities you have proven. So just try to change them to the same. Left side and the right side, they are identical. Then you have proven this trig identities. So example 3. Prove this one and compare the left side is more complicated. We are going to start from the left side. And there are more than one way to do it. So sine squared theta all over 1 minus cosine theta. So one way we could do is the right side you have 1 plus cosine. We could times 1 plus cosine theta to both numerator and denominator. Because the left side you don't have 1 plus cosine theta. Then after that we are going to keep the numerator there but multiply the denominators. So 1 plus cosine theta we don't touch it. So numerator is sine squared theta. Then denominator you times 1 plus 1 minus, you are going to have the difference of squares. A plus b times a minus b give you a squared minus b squared. The reason is plus ab minus ab, the middle term cancel out. So it will be 1 minus cosine squared. And we know from the Pythagorean identity, sine theta cosine theta is 1. That is in our hexagon. So it's this one, sine squared plus cosine squared equals 1 squared. That is our Pythagorean identities. So I together squared, I together equals 1. So then it will give you that 1 minus cosine squared give you sine squared. So you will have sine squared divided by 1 minus cosine squared is sine squared. The reason for that is sine squared plus cosine squared equals 1. Then we move the cosine squared to other side. You will have sine squared equals 1 minus cosine squared. So also you could change the sine squared theta to 1 minus cosine squared theta. Or you change the denominator to sine squared. No matter what, it is 1. And don't forget, you still have, you times the denominator, you still have the numerator left here. So we don't touch it because it is same as your right side. So this cancel out, you will have it equals 1 plus cosine theta. Then that is your right side. So now you have proven that left side equals right side. Therefore, it is proven. And this question is done. Then you could pause and practice. So example 4. It asks you to prove 1 minus sine squared theta equals sine theta, cosine theta, cotangent theta. So both sides looks like a little bit complicated, so we could start from both sides. So left side and the right side together to change them to same. So 1 minus sine squared theta, we know that is cosine squared theta. So we have the sine, cosine, then 1. So this squared I together equals 1, then go backward. 1 minus sine squared give you cosine squared. It's same as a squared plus b squared equals c squared. So then sine squared plus cosine squared equals 1. So a squared equals c squared minus b squared. C is 1, b is cosine, so 1 minus cosine squared, 1 minus sine squared is cosine squared. Right side, we want to change everything to sine cosine. So sine theta, cosine theta, and the cotangent is backward. Cotangent is here, so equals cosine divided by sine. This is from the hexagon. Then sine, we could imagine that everything, this is divided by 1. Change it to a fraction, then numerator, denominator, the common factor we can cancel out. So cosine theta divided by sine theta is 1. Then we have cosine times cosine give you cosine squared. Then you will see the left side, the right side, we change them to something that they are identical. Then we could write, okay, now left side equals right side. Then therefore, it is proven, so it is done. So what we have done is we change both sides to the same, something identical. Then example 5 is more complicated. So compare these two sides. You will see the left side is more complicated. We are going to start from the left side. And they are fractions, so we want to change them to same denominator. Then it means the first term, first fraction, we are going to times 1 plus sine theta to both top and bottom. Numerator and denominator both times 1 plus sine theta. And do the same thing to the second rational expression. So cosine theta then times 1 minus sine theta. It's kind of like cross multiply this times both numerator, denominator, and this one times both numerator and denominator. 1 plus sine theta times 1 minus sine theta. Then after that, you will see you have the same denominator, then we could add the numerators together. So when we add numerators together, we want to collect the like terms, then we want to expand to, in order to collect the like terms. So multiply cosine theta times 1 is cosine theta, then cosine theta times plus cosine theta times sine theta. Then the second rational expression times cosine theta times 1 is cosine theta. Cosine theta times negative sine theta is minus cosine theta times sine theta. And the denominator is difference of squares, again, is a squared minus b squared sine theta. 1 minus sine theta squared is c squared minus a squared give you b squared. b is cosine squared theta. Then cosine theta plus cosine theta, they are the same term, some like term, so 2 cosine theta. Plus cosine theta minus cosine theta sine theta, they cancel out, it's 0. After that, we are going to cancel the common factor out, it's cosine theta, so 2 over cosine squared theta divided by cosine theta give you cosine theta. And that is your right side. And this is done. So cosine theta cancel out, this 1 degree minus 1 is 1. Then, therefore, it is proven. Then we are going to see the next one. Example 5, you could pause and prove it. Try it by yourself first. So this one, they have the adding, so we want to start both sides. Both sides looks like not so easy. So tangent theta plus cotangent theta, and this one we have 1, 2, 3, 4, 4 ratios. We don't want to deal with 4 ratios. We may want to change all of them to sine, cosine. So tan theta equals the hexagon is sine divided by cosine. So that is a hexagon here. Then opposite is reciprocal. Opposite is reciprocal. This one opposite is reciprocal. It will be secant. So now it is tan theta equals sine divided by cosine. This is not divided, it's equal sign. Sine theta over cosine theta, and cotangent theta equals cosine divided by sine. So this is a fraction. I think we need to have the same denominator. We could cross times cosine theta times sine theta. To both numerator and the denominator. So sine theta times sine theta give you squared. And second term is sine theta times cosine theta to both numerator and the denominator. So cosine theta times cosine theta give you squared. We have same denominator, sine theta times cosine theta equals cosine theta times sine theta. Order doesn't matter, so we just write it as sine theta times cosine theta. And the numerator is sine squared plus cosine squared theta. And we know that this hexagon, we have this triangle is sine squared plus cosine squared equals 1 at middle. So this is Pythagorean. And then it is 1 over sine theta cosine theta. Then we could start from the right side. So right side equals, we change the secant to 1 over cosine. All over sine theta. Then we could change it to 1 over cosine theta divided by sine theta. And when we do the division, we could change it to multiplication by flip it. Multiply sine theta over 1, then flip it, becomes 1 over sine theta. Then you will see numerator times numerator, denominator times denominator. It will give you sine theta cosine theta. So it will be left side equals right side. Then it is proven. So the last one, so we start from both sides and change them to something that are identical. So the last one is proven. This one, you will see that the left side is more complicated. We start from the left side. And again, you have 1, 2, 3 ratios that we are not quite familiar with. We could change them to sine, cosine. So cotangent is cosine divided by sine. Then squared is just cosine squared divided by sine squared. Then 1 plus tangent is sine squared divided by cosine squared. Then continue, we are going to do the numerator time, change the adding to same denominator, so it will be cosine squared. Then change the 1 to both cosine squared times cosine. 1 times cosine squared, 1 times cosine squared. Once we have the same denominator, we could add the numerator to the top. Then sine squared plus cosine squared, we know is 1. So, and the numerator times numerator, denominator times denominator, this is common factor we could cancel out. And this add together is 1. So 1 over sine squared theta. So here, sorry, it should be cosecant squared. Then 1 over sine squared, it is cosecant squared. Then it is right side. So this is proven. So in this video, we have covered the 8 trig identities, and you could use them to prove other trig identities. We start from the more complicated side, and sometimes if the trig ratios we are not familiar with, we want to change them to sine, cosine. And in this video, we have shown you the trig, the hexagon, to help you to memorize all these 8 trig identities. Okay, so how to use this one? Tangent equals sine divided by cosine. Cotangent equals cosine divided by sine. And the diagonal is reciprocal. The 3 color triangles represent the Pythagorean identities. Top 2 squared add together equals the bottom 1. So that is all for this lesson. Thanks for